Is the PDF?
Yeah, that's the PDF.
Oh, okay, that's fine. Hello, good afternoon. My name is Sergio Contrino. I work at InterMine at the University of Cambridge. I will talk about the work we have done to make InterMine following more closely the FAIR data principle. I said we, but actually the work that I will present was mostly done by Daniela Butano, that couldn't be here today. And I will also use some slides from Yodi. The outline of the talk, I will describe briefly what InterMine is. I will mention FAIR, and then I will illustrate the four actions that we took to obtain this closer adherence with the FAIR data principle. So InterMine is a data warehouse system, integrates data from multiple data sources. The data is then stored in a Postgres database and is Java-based. Accessibility to the data is done through web apps. This is the homepage of UNMine. That is one of the two mines that we maintain in-house. There is also a vast portfolio of web services, and we also provide a client library for the more common languages. And accessibility is also ensured by a very sophisticated query system. Sophisticated in the sense that it is the most generic query system, and results are displayed usually through results table, like the one that is depicted here, where you have also some summary information for each column. There is reusability is provided by the export function. You can export the data that you have queried in a different format. There is also reproducibility, because we automatically generate the code for reproduce this query in the languages we said before. Other way to assess the data is through visualization tools, and we have also a few statistical tools like enrichment on list of data. We are building a new user interface for the InterMine, and this is entirely powered by web services. You can play with it it's in a beta phase, and you can play with it at the URL below there. And Yo is also presenting a poster, so you will be very welcome to inquire there. So FAIR, as you all know, is a set of principles for optimal use of research data, and also is a nicely working acronym about findable, accessible, interoperable, and reusable. In reassessing how InterMine is adhering to this principle, we use mostly the two references that are indicated there. And from this assessment, we came up with four action items that we broadly divided here in the FAIR principle categories. We needed to improve our access URL to the data that the mine display. We wanted to add markup to our web page for machine findability, improve the ontology usage, and also the license information. And I think there is a... So the bigger issue was probably the permanent URL, the access to the data. We are a data warehouse, so mostly we integrate data from other sources. So we have, but we have also some mine that is a sort of principal provider of the data that is displayed. These two cases, we have devised a a schema to deal with these cases, and with the added situation that we also want to provide data for the decoration of the web pages, and we use a slightly different strategy that I will illustrate now. And there is a blog post regarding all the working for deciding how to deal with the URL. So the first situation is data that we integrate from other sources. We wanted to provide a local identifier that was easy to remember and could be stable. You have to notice that InterMine is built each time is rebuilt, and so at the moment the main identification was an identifier that was changing at each iteration of the build. So for this stable identifier, local stable identifier, we decided on a schema of the type illustrated here, data type plus identifier. The data type is the class of the object we are displaying, in this example, the protein. And as an identifier, we use the primary identifier from the main source providing the data. In that case, UniProt, so you see here a UniProt identifier. For us, the great advantage for us compared to other possible solution was the readability, of course, but also the fact that there is practically no configuration needed for this sort of schema. Since InterMine is used by different group, that we didn't want to burden other developer with even more configuration. This same datum that we wanted to make easily accessible. When we were going to decorate the page with permanent identifier that are machine readable, we didn't want to multiply permanent identifiers that are already there. So, for example, in this example of a protein, or UniProt protein, we decided that for RDF generation, for example, we will be using the permanent identifier that the original source provide. But as I mentioned before, sometimes the mine itself is the sort of principal source for the data. In this case, we use a similar, is the same schema, of course, with the type and the identifier. The identifier now is really local in the sense that is from the mine itself. But we also plan to register the mine to identifier.org, so that through identifier.org we can furnishing a permanent URI. So the permanent URI that you see there is the one that will be also in our RDF generation. That illustrates the importance of registering your resources. We do that with identifier.org, and we have planned for a few more things to do with them, like being as a secondary source for the data. And all InterMine are also registered with file sharing, that link to all the main InterMine page, the home page. And we link also, we register also some tools with BioTools. So I talked before about the decoration of web page. And at the moment, the main thing that we're doing is adding JSON-LD annotation to web page. We are these are then indexed by the Google dataset search, and as you know, bioschema.org is extending the schema.org for life science, and we will follow this extension when they happen. At the moment, the two types that we are for which we are producing JSON-LD are data catalog and data set. Data catalog is in the display in the mine homepage, and the data set for each report page for each data set. And as soon as bioschema.org come up with a new profile for gene, protein, and so on, we will add also those. And I think that should be pretty close in time. This is an example for JSON-LD for the data catalog. It's just to show that, for example, this is the situation for fly mine, the other mine that we maintain in-house. There is a collection of data set. Here I just showed the data set flybase. What happens now if you search in the Google dataset search for flybase, you also get flymine as a secondary data source. InterMine is based mostly on the sequence ontology database, but for improving the interoperability of InterMine data, we needed also to annotate more extensively our usage of ontology. In practice, we annotate our data model with all the ontology terms that we need. This ontology annotation will then be used during the RDF generation. In the process of filling up all the holes that we still have with terms in class or attributes in the mine, we use the bioportal biontology.org, and the ontology lookup service to find them. And we ended up with 6 ontology that we are using to cover all InterMine. So this is just to show that we did all the work, of course, for the sequence ontology and the additional data type that we have in the core InterMine model. But InterMine is, as I said before, extensible. So if an InterMine, a mine developer is extending the sequence ontology term that is used in the mine, this is also automatic, but for other terms, this search is for annotating them, that is still manual. And I think it has to stay like that because you need also the domain knowledge to do that. And we are back to data license that is, as said in the previous talk, said is needed for reusability of the data. From the technical point of view, for us was not a big issue. Technically, it's rather straightforward. We added a license field to the data set. We updated all our parser to record data licenses. We added the data license for all the core InterMine data sources, and we display it in the report page for the data set. This is more or less what you get for human mine, I think. As you probably notice, and being wiser from the previous talk, while technically it was not difficult, during this work we noticed that very few, a sort of a minority had a clear data license from the data set, the data sources that we were using in the core InterMine. Apparently we were being a bit less fortunate than said, so we have even worse statistics here. And again, we had the same problem that sometimes the information was confusing and not clear and so on. And also for that there is a blog post that dwell a little bit more on this. All these features that I illustrated are released in InterMine 4.0. That is, even if we did a switch of version number, it's not disruptive, so you can update without, for example, adding your license. That won't break your code. What we plan to do next is to generate the RDF that is still missing from the action plan that I showed at the beginning. And with this, I would like to thank you, to thank the organizer for inviting us here, and well, especially the BBRC that is actually funding this specific work. So thank you very much.
Thanks. Are there any questions from the audience? Otherwise, on Slido, there are none so far. So if you want to submit some on Slido, go to slide.do and type in the BOSC hashtag and give your questions.
I was just wondering for your licenses, are those self-reported licenses, or did you go in and look for the licenses that were on those resources?
So you're asking if it was software or data license?
For the data.
Oh, okay. So yes, in a few cases, it was not clear if it was a software license or a data license. But the one that we attached to it were data licenses.
Right. And so in those cases, you determined what license it was, but those weren't self-reported. So. Oh
yes, that came from the source. So yeah.
Okay.
Yeah,
okay.
Yeah. Thank you.
Any other questions? That seems to not be the case. Then thanks again, and we can move on to the lightning talks.